Record. Okay, so what we need to talk about is the molecular geometries of different molecules. So the easiest one is linear, right? What happens with linear geometry? So this is super easy, right? There's 180 degrees between the bonds. Pretty simple, okay? So for instance, we've got carbon dioxide here, right? So the electrons are evenly distributed, and there's no, same with beryllium dihydride, right? Beryllium dihydride? I have no idea what this would do to you. No clue. No idea what it would do. Okay? I don't know.
But how easier than eating it?
I don't know.
That's like the basic molecule, dude. Yeah.
For me to know if it's gonna, I'm gonna know every single molecule.
Yes.
I'm gonna know every single molecule and whether or not it will light on fire.
Dude, what are we lighting on fire?
Beryllium dihydride?
Right now?
No. They want me to know if a random molecule
is oxygen higher on the reactivity table than beryllium?
Oh gosh.
You're a science teacher. You should know the reactivity table. You act like you know everything in chemistry.
Yeah, so
That one's not high.
well, light on fire. I mean, that's
It just has to be higher on the reactivity. It's like you stick some aluminum in a bucket of rust and light it on fire.
okay.
Well, let's find out.
Anyway, so linear. Let's just focus on the geometry, shall we?
I gotta read that.
Okay. So linear geometry. This is simple. Okay. What were the other ones? Trigonal planar. Trigonal planar. Okay, nice and easy. It's on a plane, triangles. Why does this happen?
Because it's got your lone pairs.
Yeah, you've got the electron pairs on either side. Wait, this is not trigonal. That's not even trigonal pyramidal. I don't know what that person is thinking. Where's a good diagram that shows the electrons? I don't see a good one that shows the electrons, but it's 120 degrees, right? 120 degrees. So they spread out as far away from each other as possible. VSEPR.
How do we know which shape they're in?
How do we know which shape? So you're using your Lewis dot structure, you can determine their shape. Okay? Linear, trigonal planar. We can end up with bent as well, right? If instead of a third molecule here, or third atom here, we have just a lone electron pair, right? Tetrahedral, so this is when we've got four, so for instance, methane, right? So CH4. Methane, we have a carbon in the middle with 4 hydrogens around. And then what was it? Ammonia, right? NH3? Yeah. Is trigonal pyramidal. Okay. Yeah. Yeah. Ammonia, NH3 looks like that. And then bent. Bent is just like with water, right? Okay.
I love how they just call it bent. rather than something fancy.
Yeah. Yeah, I don't know why that is.
It's so fun how we use some Mickey Mouse here. Negative sign.
Bend. Yep. And then we can get trigonal bipyramidal, right? So trigonal, you have 3 atoms coming off the central atom with 2 at the, what I call like the north and south poles, but that's not the correct term. Then you get these weird ones, sawhorse, T-shaped, and linear. Okay. Where you can end up having lone electron pairs that take the places of the atoms in the molecule. Then octahedral, which is 6 pairs, 1, 2, 3, 4, 5, 6, or 6 bonding. And then square pyramidal, okay? So this is the Vesper model, all right? And the best way to understand what you're looking at is by making a Lewis dot structure and then taking some time to recognize where the electrons and where the atoms are going to go so you can understand what it is that we're looking at. So when we talk about the, no lone pairs, 1 lone pair, 2 lone pairs, 3 lone pairs, 4 lone pairs, okay? Okay, same thing here. So when we talk about molecular shape is different than the molecular shape. Okay. When we're talking about molecular shape, we're only talking about what? This one? Or is that? Hang on a second.
The A one? It's like
Yeah, I don't think that would be something you'd see very often. Because this is octahedral. Right?
It doesn't have 8.
1, 2, 3, 4. I know it has 6.
Octagons are 8.
I know. I don't know why. Boo. 6 electron groups is octahedral geometry. I don't like it either. It's just like how October is the 10th month.
Yeah, except I had people to blame that. Yeah, 2 people in particular. Ooh.
Yeah, Julius and Augustus, jerks.
Yeah.
Because they were like, oh, I just want to have a month named after me. Oh, and guess what? It has to be in the middle of the year. And also, guess what? It has to be long, so I'm going to steal a date from February. Way to go, Julius and Augustus. You're the world's, like, all-time pricks.
Well, actually, except for this guy.
Whoever said that something was 6 pairs is octahedral.
Like, how many legs do those octopus have? Yes, it's right. Let's make it official right here right now.
Most squids have 6 arms and 2 tentacles.
They're not called octosquids.
They're not called octosquids. That's a good point. Okay, so when we talk about these shapes, okay, we talked about the molecular shape versus the molecular geometry. Okay, these are all kind of the same thing, molecular geometries. But we need to understand that when we're talking about the shape of the molecule or the geometry of the molecule, we are only discussing the atoms. We don't include the electrons in the name of the, so for instance, bent, right? Really what's happening is you have a lone electron pair here, right? So if you were considering the electrons, it would still be a trigonal planar, but it's bent because we only consider the actual atoms as a part of the geometry and the shape, okay? So here's what I want you to do. I want you to turn to page 427, no, 426. And we'll do some reading from there. So people watching at home, turn in your books to page 426. We're going to do some reading. I'm going to end the video, but I want you kind of on your own time to do the reading of the you know, we might be able to just skip that part of the reading. Let's go to 430 and talk about the effective lone pairs, because I think we have the geometry pretty well. We understand what the shapes are, right? You have linear, you have trigonal planar, you have octahedral, you have tetrahedral, you have trigonal bipyramidal. Okay, so understand those. We're going to read it from page 430. That's going to conclude the video. So we're going to do some reading of 430. It's not a lot of reading, to be honest. It's mostly pictures through 433. Okay, so 430 through 433. That's the end of the video.